Okay, cool. So I came to Puppet a couple years ago, and we really had no real testing. We had ad hoc testing being done on our developers' laptops on VMs they'd rolled themselves with Fusion or with Vagrant and all sorts of different environments. And lo and behold, when we shipped product to our customers, community, nothing worked. And that was something that really needed to be solved. I came on and I started trying to address the problems of testing at Puppet. So we were a small company, as you might know, and instead of just doing a traditional QA environment where you have developers who make builds and throw the builds over the wall to QA, we actually work really close between the devs and the software team and our operations team. So actually our operations team really starts smoke testing our code before we actually put RCs out to the world. So we actually take our RCs and actually put it into our production environment in-house. If our software cannot pass our in-house production environment, then we do not release that RC, and that RC does not become part of our Puppet Enterprise product, which is not really a traditional QA environment. Often QA and developers are kind of put at odds. We do not do that. We sit together, work together, we're all part of the same team. Our team is really small. We actually have focused on hiring very sharp people who have development skills, Unix skills. We do not do button pushing testing, so we don't get new builds and people manually test. Everything we test at Puppet is almost entirely automated with code that we write ourselves. So until recently, our team was only 2 people. We are now up to a team of 3, and that's to test the entire Puppet matrix, which is actually a lot of software, as I'll get to shortly. We also have our developers' own testing as well. We develop tools and infrastructure for our developers, so our developers are actually intimately aware of all of our testing tools and testing harness, and actually have taken part in growing those tool sets to make them a lot more robust. And of course, then there's the community who does a lot of testing for us, as many of you probably know. Sometimes good, and sometimes not such a good situation. But bug reports from the community and bug fixes from the community actually play a really big part in what we do. It's not the whole picture, but without the community testing, we would actually have to have a much larger technical team just to do testing. So we are, of course, always appreciative of your guys' work. So what do we test exactly at Puppet? It is a lot of stuff, actually, and the matrix for testing Puppet could actually be multiple millions, right? So we actually have 400 GitHub repositories, and we currently support 60+ operating system platforms. So that's all your ELs, Debians, Ubuntu, 64 bits, 32 bits. We test against the 0 versions, all the updated versions. Then there's Solaris, AX is on the way, and multiple Windows platforms. So this is like a huge operating system matrix alone. And then we have a large set of test configurations. So as many of you know, we now have dashboard and console off and all these different pieces that are being added to Puppet. All that increases our testing matrix exponentially. And then we go into our browsers. So we actually do browser testing right now on 7 browsers with about, I think, across 4 different OSs right now. So that's another huge piece of our testing. And then, as many of you know, there's the legacy Rubies that we support. Ruby 1.8.5, 1.8.7, multiple patches. 1.9.3 is our latest supported with patch level 0 and patch level 125. So all this is tested every day on those different versions. And then in addition, as you probably know if you've rolled Puppet yourself, Puppet, Factor, Hyra, and Collected, standard lib modules, various versions of those, plus all the different modules that you may be using in production yourself that come from our Puppet fork. So all that stuff is tested on a daily basis and a part of our continuous integration system. And really the important thing is how we actually get all this done is kind of the important thing. And we have really embraced continuous integration and continuous delivery. So with a small team like us, like ours, without some sort of automation around it, there's no way that we could get all this work done. So we automate heavy at Puppet. So, like I said, our continuous integration and continuous delivery ecosystem is 400 repositories, of code, and we actually maintain 3 Jenkins environments that are running hundreds of jobs on a daily basis. And those are all integrated with GitHub. So actually GitHub and our Jenkins environment are always communicating. So if someone pushes a change to a repository, then we automatically kick off a test, check out the code, run a bunch of tests. If there's failures, we get emails, and we go and investigate those. We have a Jenkins environment that's public. I don't know if any of you ever go to jenkins.publiclabs.com, but you can actually see our continuous integration system in action. Anonymous access is set up, so you can actually go in and see all of our jobs running, and it's kind of huge. We use a large VMware vSphere cluster in-house to maintain all of our hosts. So with all the operating systems we need to support, we maintain this large cluster. It's roughly 60 hosts at the moment, but it's always growing, and our cluster grows. We also have an AI Xbox in-house, and HPUX is coming soon. I forget, but a lot. And those machines, and the Slayers machines actually, I do forget, the Slayers machines actually are physical, of course, because we can't virtualize all our environments, so there are some stuff that we have racked, but we do try to use a lot of virtualization to save costs, of course. Then we do scale testing on a regular basis. So scale testing is kind of an interesting problem. If you're a small company in particular, you really can't afford to go to one of these large labs at Intel, which is like about $100,000 a week for a small lab. So we actually use EC2, and we actually wrote our own code. We actually use our own code. Actually, we use Puppet Cloud Provisioner, and we scale out 500 to 800 nodes in EC2 in about roughly 2 hours, and then we actually are able to install Puppet on those and have a fully running Puppet environment with between 500 and 800 machines in usually under 3 hours. That's kind of really cool. Not so many people could spin up that much in EC2 that quickly, so we actually are able to do serious scale testing on a repeatable basis using our own code. It's really nice for us to be consuming our own tools to be doing our testing. Then there is Sauce Labs, which is what we use for our UI work. I don't know if any of you have ever used Sauce Labs, but Sauce Labs is really cool. Sauce Labs maintains a pool of VMs, and you actually just say, give me a Windows VM with IE8, and you point it back at your own infrastructure, and it actually runs your Selenium tests without you having to actually maintain all these Windows VMs. So we actually use Sauce Labs, and we run 20 parallel jobs regularly, and it's actually, we just brought that online about a month ago, and it's really useful. If you guys have questions about Sauce Labs, I could talk to you guys about it afterwards. And we also have traditional tests that most of you have seen. Like, we do heavy RSpec and unit tests on a regular basis. Every single commit that gets made gets a full battery of unit tests and spec tests, and I think we have something like 40 or 50,000 spec tests that get ran for all of our repositories. So it's a huge amount of testing that gets done for each branch of Puppet. And then we have unit tests that are more at the OS level, the integration level. And then we have full-on systems integration tests, that are actually installing our product onto real live VMs and then doing real tests to see if the software actually works the way it's supposed to work. To accomplish that, this was actually a fairly daunting task to take. And all of you have deployed Puppet. I don't know how many people use PE. How many people are using Puppet Enterprise? Just 1, 2, 3, 4. Okay, a few people. So the rest of you, how many people are using Puppet in production? Wow, okay, everybody. So rolling Puppet out on your own production environment, you probably know it's not easy. Now imagine doing that like all the time, every day, right? Every time you get a new build, you have to blow away everything, rebuild an environment. So to do this, we actually wrote our own test harness. It's actually kind of a cool project. Some people of you know about it. So this is my super high tech slide actually that I made. I'm sure you guys are really impressed by that. It's maybe hopefully better than a canned slide. So what this is here represents the day in the life of testing a PE build at Puppet. And I kind of wanted to, I sketched this out to try to give people a real idea of the complexity of what we do on a daily basis for testing Puppet. So this is not even testing Puppet open source or Puppet modules or anything. This is just a PE build, right? So over here is the Puppet Labs dark matter pool. That really is all of our repositories where we actually are constantly testing Puppet on a daily basis. All of our spec testing, unit testing, all that stuff is happening over here. And every once in a while, something is strong enough to actually escape the gravity well and winds up here into our massive Jenkins system. And this is where actually a PE build is initiated. So we actually run a really large Jenkins system, and it goes through, it fires off a build on a Jenkins agent. And then the Jenkins agent interfaces to these various machines, which are actually virtual machines that we have built in-house, our builders. And each one of those builds packages for the intended platform and building of all the PE pieces. And when that is done, this goes to our distribution server, again, a very large virtual machine in-house that we maintain. And from there, this gets consumed by another Jenkins environment, a Jenkins agent, and this is running our systems test harness that we developed in-house. And the systems test harness actually integrates into everything. It actually is able to control and talk to vSphere infrastructure. So it actually is able to talk to our vSphere, find the correct VMs, revert them, install Puppet, configure it, and then run a slew of tests. And this is like a testing pipeline right here. The first thing we do is we do installer tests, and if you've ever installed PE, which I know is not very many of you, it's a really big installation procedure. It's quite intense. So we actually, after this, if you have failures here, we don't go any further. That's the end of the testing. But usually we wind up here doing acceptance testing, which is the full testing Puppet, the Puppet DSL, all the Puppet features. Then, if this is passing, we move to upgrades. And if any of you are early adopters of PE and have ever been through the upgrade testing, you know that sometimes upgrades are a bit of a pain. We have put a whole bunch of testing around upgrades. We find a lot of bugs there actually. We've fixed many things. We go on to uninstaller testing and then our UI testing. The UI testing, again, our test harness is actually running and talking to the Sauce Lab service, which is outside of our network. And then the Sauce Lab service hits a Sauce Labs tunnel that we run inside of our network, and that is then able to talk to our VMware vSphere environment and actually run against our live Puppet infrastructure. Then that's my notes on over here. After all this testing looks good here, builds are promoted from our distribution server and go out to EC2's S3 environment. You guys know about that. And then in EC2, then we start spinning up our nodes and do the 500 plus scale out tests. We also do testing against Forge, Puppet Forge. We have a Puppet Forge in-house for testing. We have LDAP servers and AD servers for doing external authentication. This is all stuff that our testing, this is all part of our testing environment. Questions about this? I'm talking probably fast.
Do you actually have the whole test pipeline itself automated? So
yes.
Stand up and slates and all that.
Yes. So if we kick off the build here, these things get built. They get pushed automatically.
Oh no, I mean,
sorry.
The build off the Jenkins server is automated.
Yes.
Could you blow away or
yes?
just
Sorry.
pipeline?
Yes, we actually can use our Tyler's Puppet module, our Jenkins module, which we kind of improved a bit, or at least made it useful for us. So actually, most of our testing, infrastructure that's not specifically the Puppet code itself is Puppet House, yes. So we actually do utilize Puppet heavily for managing all those systems, including in EC2. We actually run a Puppet master in EC2 for managing EC2 environments that we need to have in a good state. And we even run a Jenkins node out on EC2. That's also Puppet House.
So every time a check-in happens that gets promoted and the builders pass those tests, you on demand using vSphere to spin up like a ton of different
yes,
a ton of different Linux environments.
on here is not on a per commit basis. The per commit testing is like spec testing and unit testing. This is, we've decided that there's enough stuff that looks good in the RC world actually, when we say there's an RC that's going to be promoted to be a Puppet enterprise build. So we take that code and we do basically, it is basically a one button operation. We essentially tell this Jenkins master to go do the build step. And everything else actually happens automatically. And this is nearly a full day of testing. This is about 6 hours roughly, maybe more depending on network speed.
So like where do you put the line of only doing the artifact testing versus like the EE test where you spend 500 million involved?
Yeah, so just to be clear, the EC2 stuff, I do not have that set automatically to happen. I could actually, but that is too expensive of a procedure. We get like multi-tens of $1,000 bills from EC2 all the time, right? So we really say, okay, this is like we're getting close to being our final build, our meteor stones for our final build before PE release, and then we go out and basically like I pretty much play the button or fire off the script and it builds out the EC2 environment, and then I come back in a couple hours and there it is.
Do you tag like the golden build or something?
We do, yeah, we have RCs, right? Exactly, we tag, and all of our builds, everything lives out on the distribution server, so everyone inside Puppet knows that we're pushing new builds, and they also auto promote from internally on the server. We have an area that's like called ready for testing, and then there's ones that are like kind of like smoked, and people in house start using them. So professional services people use it. Even some people like our marketing are actually really sharp. They start installing the builds, so everyone actually consumes our builds, not just us.
Sure. And like straight up stupid question, the sauce stuff
Yes.
is just UI testing your drive.
It is Selenium. Yes, it's Selenium based testing. Yes, it's actually only UI stuff. So yeah, as you can see, this here, our test harness, this actually runs everything. It's actually integrated in the entire environment. Without that testing harness, we would not be able to do what we do here. So I know we're kind of getting a little bit short on time, but I want to just like briefly talk about the test harness because it's kind of cool. So it's configuration driven. The way Puppet gets installed is actually dictated by what's in your config file. So we can actually, and it's a YAML config file, it's like really easy to set up. So you can actually change the OS and the configuration of your testing just by changing a few lines of YAML, and then you rerun the test, and now the test will run in a very different manner. So it's really useful for us. Our test harness is client-server based. I don't know if any of you have ever tried to do client-server based testing. So there are tools out there that are like really expensive and really difficult to implement, and there's all this extra coding you have to do anyways to make them work, and they're $50,000, $100,000. And then there's some free ones like Staff and Stacks, if you've ever been involved in like the Linux testing project, which are super hard to use. They're not really intuitive, and they are really not, I think, sophisticated enough for what we needed to do. So we've made our own. And we've integrated, like I said, we have integrated with vSphere, Fusion, and EC2 all from the same test harness. So people learn the harness and then can automatically spin up test environments in any of those areas without ever doing anything different. That's just the config file dictates where you will be testing. We also have implemented a Puppet-centric Ruby DSL, so people who are not super good Ruby coders can actually use the DSL to do very simple natural language testing. So you basically say like, do this thing on the master, and it automatically is able to grab standard error, standard out, parse and do asserts and all this kind of stuff, logging, JUnit XML logging, standard human readable logging, all this kind of stuff, very simply. And it's cross-platform, so this actually runs on Linux, Unix, and Windows, and that's a really big win for us because we support so many platforms. And I just wanted you guys to look at, like, this is actually a real config file. So we have two hosts defined here, a CentOS box and an Ubuntu box. And we've actually defined with the CentOS box, it's going to be a master, an agent, and a dashboard. And that's its platform. So obviously it's an L6 box. Its role is only an agent for the Ubuntu box. Let's say 32-bit Ubuntu. This is an arbitrary configuration area where you can actually add arbitrary configuration data to be consumed in your test if you need to add something like, say, you have an NFS server that you want to do some testing on, right? So you can, all this here will be in a globally available config cache. So all the tests can see whatever in here, so you can actually extend the harness by simply adding data here. And these files get really big. Like we actually have like, like a big red hat box with like many agents behind it. Sometimes all of our agents. So we'll have like Windows, Solaris, and everything set up there. And if I was to like if I simply changed the roles and like put the roles master and dashboard down here and left this only agent, then rerunning the harness would completely change how this is run. But then this would become a Puppet master with a dashboard running, and then a whole set of tests would run on this box versus the way they would be run on this box, right? So kind of cool. Makes it really easy for us to do testing. So this is what our test harness, which is called systest, by the way. Like I said, it's a natural language DSL. So on is like one of the main verbs. So you said like on hosts, do Puppet version, and you can do some like post processing on like do. This is like Ruby, right? Hosts are all the hosts that you've defined in your config file. So this would run on every machine, Windows boxes, everything. We also have, like we use the word on, agents. This would be all the nodes that you've defined in your config file that are configured to be a Puppet agent. And we have certain keywords like factor. So this would be running factor in the correct factor environment. And like you just said, pull up the kernel major version. And an important one is the master, of course. So we have like special keyword for master. There's only one naturally. That will probably change in the future. But we have special Puppet-specific words that you can get cert information, and basically all your Puppet commands can be called this way. This allows us to run all sorts of Puppet commands, get the data back, without running a bunch of test harness code on the actual machines being tested. This actually returns everything back to the central system. Same thing here, dashboard. The dashboard host is automatically known just by what you define in the config file. And the apply manifest is, since obviously doing manifest is a big deal, you can define a manifest in your test, and then you just say apply manifest on all your agents. This will run whatever manifest you define in your test on all the agents in your config, and report everything back, what passed, what failed, error output, and also you can override Executors. So as you guys know, sometimes running Puppet, you don't get 0 or 1 back as an error. You sometimes get 2 or 4 or 6 or 3, and sometimes those are desirable states. So you can override what an acceptable execute is. So it might be 1 is actually a passive. So if you said this, then if you return 1 from your test, then this test will pass. All right. So just show you. Oh.